All right, guys, 9.3, we're going to move into circles now. So by the end of the lesson, you need to be able to do two things. Write an equation of a circle and also graph a circle. Now, I'm in my office for this recording, so it might be a little echoey. I apologize. But let's get into it. Equations of circles. So assuming that x comma y are the coordinates of a point on the circle at the right, the center will be at h comma k. Okay, so h comma k, some people get confused with this. That's just another way we identify an xy coordinate, but it's a specific xy coordinate for the center. You'll see the same thing when we get into with an ellipse, we'll have an h and a k, and with a hyperbola, we will also have an h and a k, but it always stands for kind of the center or the vertex or middle of something. And the radius in a circle is the r value. So you can find the equation of the circle by using the distance formula, and the reason for that is we know that the distance from the center to any point on the circle remains the same. That's called the radius. Okay, so notice that if you took the point at the center and any point x comma y on the circle, and you found the distance between them, that'll be equal to the radius squared. All right, so that's all the equation of a circle is. So when we see this equation for a circle here, x minus h squared plus y minus k squared equals r squared, remember that that's just the distance formula, and it's marking the distance from a center point. Okay, so x minus h squared plus y minus k squared is equal to the radius, or that distance squared, okay, from center to any edge point. So let's go ahead and, this is an equation for a circle that does need to be memorized. Definitely spend some time with it, but it's pretty straightforward. Know that h is always dealing with a x value and k is always dealing with a y value. So the standard form of the equation, if we don't move anything from center, we would have x squared plus y squared is equal to r squared. Okay, as soon as we move that center to anything besides 0, 0, then we need to bring in the h and the k. Okay, so the only reason that this one doesn't have h and k is because h and k is equal to 0, 0. So it doesn't change the distance at all. All right. So here, as soon as you change it from 0, 0, then we need an h and a k. And it's whatever make these go to 0 is what gives you this coordinate here. Okay. So let's go ahead and try one of these out. So this is example 1. It says a certain Wi-Fi phone has a range of 30 miles in any direction. If the phone is 4 miles south and 3 miles west of headquarters, write an equation to represent the area within which the phone can operate via the Wi-Fi system. Okay, so sounds like they want the area of a circle here, but really they only want the equation of a circle where, if you had a coordinate plane here and you're 4 miles south, so let's just make headquarters 0, 0, right? So we're 4 miles south. We can represent that with the point, -4 in the y direction, and 3 miles west. So if you're 3 miles west, west would be to the left. Okay, so we have 4, or -3, I should say, -4. Okay, that's where our point is. So the center point would be at the h comma k would be at -3 comma -4. Okay, write an equation to represent this. So, and the radius we know is 30. So we know that x minus h, the h value here is -3, so x minus -3 squared plus y minus -4 squared is equal to the radius squared, which is 30 squared. Okay, so we can simplify this a little bit because two negatives make it a positive, right? So this will be x plus 3 squared plus y plus 4 squared is equal to 900. And that is the equation that they're looking for. Okay, so that's just plugging in our center and our radius into our equation for a circle. Now, for example 2, it says to write the equation for a circle that is graphed here. So For this one, the center is at 0, 0. So since the center is at 0, 0, we don't have to modify that at all. So this is going to be one of those ones where we have just x squared. I mean, you can put minus 0 there, that's not going to change anything. Plus y squared is equal to the radius squared. Well, the radius here, we don't know necessarily the distance here. So we have to find that distance. Okay, so to find that distance, there's a couple of ways we can think about this. This is a right triangle that has a distance of 1 in this direction and a distance in 5 this direction. So we could say, okay, 1 squared plus 5 squared is equal to the radius squared. And then in this case, that would be 26 is equal to the radius squared. And really, the radius squared is what I want. So I can stop there. I don't have to find the square root of that. All right, so this is just equal to 26 because we know that x squared plus y squared is equal to 20, or to the radius squared, which is, in this case, 26. All right, so notice the radius is not 26, it's the square root of 26. So if you wanted to find r, it would be equal to the square root of 26, but we just don't need that because in our equation, the equation for a circle is x squared plus y squared is equal to radius squared. All right, so I just kept the radius squared format. Example 2b, notice how this changes now. So this one we have the center at 0, 0. Now my center here is at the center is at negative 1, 4. It's this guy right here. So the equation for this circle is going to be x plus 1 squared, because again, it's whatever makes this go to 0, right? So if I put a negative 1 into this, it would make that go to 0. And then we have plus y minus 4 squared, because if I plug that 4 in there, that would make that go to 0. And this is equal to the radius squared. So we can find the radius. This distance right here is a distance of, it looks like that distance would be 2. And then this distance right here, it goes from in the x direction from negative 1 to negative 4, so that's a distance of 3. So notice that's a 2, 3 triangle. We can find this other piece, so we have 2 squared plus 3 squared is equal to the radius squared. So this is 4 plus 9, which is 13, is equal to the radius squared. And that's exactly where I need to stop because I just care about radius squared here. So this will be equal to 13. And we're done. Okay, so that's example 2. Example 3 says, write an equation for a circle if the endpoints of a diameter are 3, negative 3, and 1, 5. All right, so let's just get a picture of what that looks like. This is a diameter here, not a radius, right? So at 3, negative 3, we have a point, and then at 1, 5, we have a point. Okay, and this is a diameter of the circle. All right, so what we could do here is we can find the middle of those two things, and that would be our center. So let's go ahead and do that so we can start with that. If we find the middle of the points of any diameter, that is the center. So let's go ahead and add our x values together, 3 plus 1 and divide by 2. This is just our midpoint formula, right? And then negative 3 plus 5, add those together, divide by 2. So this will give me 4 over 2, which is 2. And here we have negative 3 plus 5, which is 2. 2 over 2, which is 1. So at 2, 1 is our center, and that seems to match up with my rough sketch there. Okay, so that's my center, my h comma k. So far, I know my answer is going to be that x minus 2 squared plus y minus 1 squared is equal to some radius squared. Now I got to find the radius. Okay, so to find the radius, I can use my I can now do a couple of different things. I could use my just my distance formula and go from this point, one point, to the center now, since I know my center. So if I use this point up top here, this distance from, that's 1, 5, right? So if I look at my y difference, that's going to be this guy right here. That's a difference of 4, so that distance is 4. And then I know this distance here, the difference in the x's is just 1. So I could say, okay, well, 4 squared plus 1 squared is equal to the distance squared, but in this case that would be like the radius, right? So the radius squared. 4 squared is 16, 1 squared is 1, 1 plus 16 is 17, so I know my radius squared is equal to 17. Okay, so this is equal to 17, and I'm done. All right, so a little more work there. You got to just think about what a diameter is. Remember that the center of a circle is halfway in the diameter, so you can use your midpoint formula to find that. And then example 4, we have 2 more examples, guys, and then we're done. So example 4 says, find the center and the radius of a circle with this equation. So if x and y are not being modified, that makes it very easy for us. We know that the center is at 0, 0. All right, and then the radius of this thing, remember that this is equal to the radius squared, so I could say, okay, well, radius squared equals 81. So if I take the square root of both sides, the radius is equal to 9. So radius here is equal to 9. And that's all they want for this one. And then they might, this says then graph the circle. So if you're going to graph the circle, here's center. Since my radius is 9, I know that I can go 9 in the positive direction, 9 in the negative direction, all the way around, right? So this is 9, negative 9, and then you just draw your circle here. I think I'll give you graphs on your homework sheet so you can make that very easy. But that's all you got to do for that. Okay, so since the radius is 9, you go 9 in all 4 directions, really, and then connect the points. So that's example 4. Then for example 5, the last one here, it says find the center and the radius of the circle with this equation, and then graph that thing. Okay, so for this one, what we're going to need to do here is complete the square. So again, completing the square back in. So let's go ahead and do that. We're going to combine our x terms here. So we have x squared plus 4x. Okay, to get a nice factor there, we're going to just complete the square. So half of 4 is 2, 2 squared is 4. So we have a plus 4 that we added in. And then for the y's, we can have y squared, this is all plus y squared, minus 10y, half of negative 10 is negative 5, negative 5 squared is plus 25. So I added that in. I like to underline that so I can identify it really easy, is equal to positive 7 plus 4 plus 25. Since I added it on the left, I got to add it on the right to make this balanced. And then this guy factors nicely. It's just the square root of the first term, which is x, this sign, which is plus, and the square root of the last term squared. So x plus 2 squared, and then we have plus y with this sign, minus the root of 25, 5 squared. Okay, that's just completing the square. Is equal to, in this case, what does that come out to? 36. So 36. So I know that my radius here, since this is radius squared, my radius squared is equal to 36, therefore the radius is equal to 6. Okay, my center for this thing is at negative 2, 5. All right, so you could easily then graph that, right? So you go to center at negative 2, 5. Put a point there, and then go 6 in each direction, which I'm not going to map out perfectly. And put those 4 points there, and you're done. All right, guys, that's it. We'll catch you guys next.